Hello guys, howdy cap. Welcome to my third video on Pythagoras. Okay, the part 3, the return of Pythagoras. In this video, we will do some examples of exercises with Pythagoras. Okay, in the last two videos, we talk a lot. I say a lot of things, but maybe it's time to do some stuff, right? Do some exercises. You are students, you do exercises. Okay, so what we have seen so far is that Pythagoras, the Pythagoras relationship, the Pythagoras theorem, we can do only in the right triangle. Okay, a right triangle has a right angle. Here, ABC is a right triangle because there is a right angle. Okay, first thing. And in the last video, we showed that the relationship in the sides of a right triangle is this one here. The hypotenuse square is equal to the adjacent side square plus the opposite side square. Okay, sometimes you guys write it like this: c square equals a square plus b square. Okay, because you're very lazy, you don't want to write everything, so you just remember this one. But the meaning of this is the hypotenuse square equals the adjacent side square plus the opposite side square. Okay, so here I got this right triangle. The hypotenuse is the longest side of the triangle, okay, of the side opposite of the right angle. So here BC is the hypotenuse. And then to find the opposite side and the adjacent side, we need to choose an angle, theta, okay, usually we give it the name theta. So here I say my angle B is theta. And if I say this is my angle, then the opposite side is on the other side of theta. Okay, so the opposite side is here. This is AC. All right, and the adjacent side is the last side. Okay, I hope this one everybody knows. Okay, now we're going to do some examples. All right, so remember why we want to do Pythagoras. The first thing I tell you, we want to find the relationship between the sides of the triangle. We want that in a right triangle, if we know two sides, we can find the side number 3. Okay, so this is the easiest exercise you can do with Pythagoras. Okay, I got a triangle with 3 sides, and I know 2 sides. I know AC is 3, AB is 4, and I want to know how much is BC, how much is C. Okay, right here I made the exercise again. Okay, we have a right triangle, and we know this side is 3 centimeters, this side is 4 centimeters, and this is C. Okay, I want to know how much is C. Alright, so what do we do now? The first thing we do when we have a right triangle is find the hypotenuse. Right, hypotenuse is the longest side on the side opposite of the right angle. Right angle is here, so the hypotenuse is here. This is C. Actually, the exercise here is we want to know how long is the hypotenuse. Okay, and then the adjacent side and opposite side will be these two sides. Okay, depends on what angle theta we look at. Okay, so one will be the adjacent side, one will be the opposite side. Okay, but for Pythagoras we don't really care, because remember Pythagoras, he says that hypotenuse square equals adjacent side square plus opposite side square, right? So in Pythagoras, even if you change the adjacent side and the opposite side, it's still the same thing, okay? Because it's plus. It's like 1 plus 2 and 2 plus 1 is the same thing, right? You can change the size, so it doesn't matter. Okay? All right. So we have Pythagoras, and we know the hypotenuse is C. So I'm just going to write here C. Okay, we want to know how much is C. Now the adjacent side, I'm going to say 3 is the adjacent side. Okay, so if we do Pythagoras, oops, we're going to have C square, the hypotenuse square, equals 3 square, the adjacent side square, plus 4 square, the opposite side square. Okay, now we have done Pythagoras in this right triangle. Okay. And now if you guys remember what we learned in algebra last year, this is called an equation, right? In Thai samakan, right? And in an equation we have variables to play, right? Here the variable is c. Okay, we have c squared equals 3 squared plus 4 squared. This is an equation with one variable, and when you have one equation with one variable, there is one solution. Remember solution? I think in Thai is wititam, something like this. Okay, is how much is the variable. Okay, so in this equation here, we can find how much is c, and this is what we want to do, right? We want to know how long is the hypotenuse, how much is c. Now, how do we do that? How do we find the solution of the equation? Alright guys, so I teach you algebra last year, right? So when you have an equation, you have to put all the same things together. You remember we have the like terms and the unlike terms. Yeah? The like terms, how do we find the like terms? Whoops, that's a bit big. The like terms, they have two things. The like terms, they have same variable and same exponent, right? You guys remember that? Here, how many terms do we have? In this equation, we have three terms. We have c squared, 3 squared, and 4 squared. Remember the terms, they are separated by a sign or an operation, okay? 3 plus 4, 3 and 4, they are the terms, okay? On the other side of the equal sign, there is c, which is also another term. So here we have three terms, and we have to find the like terms. Okay, the like terms, they have same variable, same exponent. The very easy like terms to find, usually they are the numbers, because the numbers, they have no variable. Okay, here 3 squared, it doesn't have a variable. Okay, it's only a number. So these two numbers, we can put them together. All right, how do we do this? What is 3 squared? How can we write 3 squared another way? 3 squared, it means 3 times 3, right? 3 squared, sam gam lang song, it means sam kun sam. Yeah? Okay, so 3 squared is 9. 3 times 3, 9. 4 squared is 4 times 4, 16. Yeah? Okay, now we have c squared equals 9 plus 16. 9 plus 16, now we have two numbers. They're very easy numbers. Everybody, you guys have been to Plateau, you know 9 plus 16 is 25. Yeah? Okay. So now it's very good because on the right side here, we only have one number. Okay? We cannot make this one more simple, more easy. Okay? It's already very simple. So now we have this equation, c squared equals 25. Now what do we do? So now, a lot of students, they have a problem with this, okay, because they don't understand very well what it means, the square in c square. There are two ways to find the solution of this equation. The first way is the very easy way, but it will not work all the time. It will work when you have very easy numbers. The first way, we do this. So you see here, c squared equals 25. And I'm sure everybody knows that 25 is 5 times 5. In other words, 25 is 5 squared, okay? So when you write things like this, here we have two sides, okay? They're equal in the middle, two sides, two terms, okay? Each side has only one term, and this term is square. So what you can do in this situation is just this. You can just cancel cross the squares, okay? Because we have only one term on the two sides, you can just cross the square, okay? So this one, when you do that, you get c equals 5, okay? So this is the easiest way to do, but you cannot do it all the time. Here we can do this because 25 is 5 squared, okay? But sometimes you have different numbers, all right? So I'm going to show you the second way, the way that works all the time, but is a little bit harder, okay? Okay, guys, so to do the second way, we're gonna need this beautiful thing here. What is this? This one, we call it the square root, okay? Or I think in Thai you say root, yeah, root 2, right? We call it the square root. What is the square root? I think in the last years you studied about this already, yeah, but I'm going to explain to you again. The square root is the opposite of the exponent 2 of something square. Okay, the square root and something square, they are opposite. What does it mean? In math, the opposite of something is something you do to go back to where you come from. Okay, I'm going to take some examples that you know already. Imagine you have a number. When you do plus 2 to your number, how do you go back to where you come from? Okay, if I do, let's say I do 3 plus 2, so now I have 5. What do I do to come back to 3? I have to minus 2, right? 3 plus 2 minus 2 is 3. So we say that the plus and the minus, they are opposite in math, okay? If we want to go back to somewhere, if we do plus, we have to do minus, okay? So you know this one. And you also know this one. If I have 3 and I multiply 3 by 2, now I have 6. How do I go back to 3? I have to divide by 2, right? Now 3 multiplied by 2 divided by 2 is 3, right? So now we say that the times, multiply and the divide, they are opposite in math, okay? If you multiply by something, to go back, you have to divide, okay? I hope you guys understand this relationship. So now, the square root and the square, it's exactly the same thing, okay? I'll take an example for you. So now, I still have 3, but I'm going to square it, okay? I have 3 square. 3 square, this is 3 times 3, this is 9. And when I have 3 square, how do I go back to 3? Right? The same way we did before with the plus and the minus, the multiply and the divide. Here, to go back to 3, we're going to do the square root, okay? If I take the square root of 3 square, this is equal to 3. Equal 3, okay? So, the square and the square root, they also opposite. You go back from where you come from. Okay, the same as the plus, the minus, the multiply, the divide, the square root, they are opposite. Okay. Okay, when you see it like this, it's very easy to understand. Okay, it's just that when you have something square, but you don't want it square, you just have to take the square root. Okay, when you have something with the square root and you don't want the square root, you have to square it. Okay, they're opposite. Alright guys, so in this equation we have c squared, so we will have to take the square root to get rid, to remove the square. Alright guys, we're almost done. So before we find how much is c in this equation, I want you to look at these two simple equations here. How do we find the solutions to something like this? C plus 2 equals 4. Here we have plus 2 and we don't want the plus 2, so we have to take the opposite, yeah? We have to minus 2. And you remember last semester when we do algebra, I teach you that when you have equal sign and you do something on one side at the equal, you have to do the same thing on the other side, okay? It means here, if you minus 2, you have to minus 2 also here, okay? So like this one we have plus 2 minus 2, that's 0. And 4 minus 2 is equal to 2, yeah? Same here. Here we have c times 2 equals 4. How do we find how much is c? We don't want multiply by 2, so we have to take the opposite. We have to divide by 2. If we divide by 2 on this side, we have to divide by 2 on the other side, okay? So here, multiply by 2, divide by 2, is like multiply by 1, okay? They are opposite, so this one disappears. And here, 4 divided by 2 is 2, okay? So when you have square root and square, everything is the same, okay? Going to remove this. In this equation, c squared equals 25. I don't want c squared, I want c. So to get c, I have to take the square root. Okay, because the square root of c squared is going to be equal to c. Okay, up, make this a little bit bigger, up, okay. Okay, c squared, we take the square root, now we have c, but it's the same thing. If we do the square root on the left side, we have to do it on the other side, okay? That's very, very important. When you take the opposite of something, you do it on the two sides of the equal. So if I take the square root to the left, I have to take the square root to the right, okay? So here we have the square root of 25. What is the square root of 25? So to find the square root of 25, we could find it if 25 is something square, okay? Then we have something square and we take the square root, we would have some number, okay? And for 25 is very easy because I told you before 25 is 5 times 5 is 5 square, right? So if I write 25 like this, 5 square, we have 5 square and we take the square root, so the square root and the square, they cancel each other, okay? So we just have c equals 5, yeah? Okay, and this is what we found before, okay, with the easy way. And we could do it before because here the numbers are very nice because 25 is 5 square, okay? But in some situation, maybe you have the square root of 27. 27 is not something that you know, okay? It's not 5 square. 5 square is 25, 6 square is 36. So the square root of 27 is harder to find, okay? So you cannot do it all the time, all right? And we will see that in another example later, okay? But here we are done with this example, okay? We wanted to find how much is c, and when we find the solution of the equation, we find c is equal to 5, okay? We didn't want the square here, so we took the square root, and now we have c equals some number. All right, so this is the solution of the exercise. C equals 5. And we just used Pythagoras, okay, the Pythagoras theorem to find this answer. All right, we knew two sides of the triangle, 3 and 4, and we wanted to find the side number 3, the hypotenuse, and we used Pythagoras to find it. Okay. And if you guys remember, in the last video, I told you about the 3, 4, 5 triangle, right? I told you this is a Pythagoras triangle, the 3, 4, 5. Here we have it. It's here, okay? Every triangle, every right triangle that you see, and two sides are like 3, 4, or 5, then you know the last side, okay? These three numbers, 3, 4, 5, they always go together, okay? If I gave you another example, where I told you this is B, and I would tell you this is 5 centimeters, then if you just look at it, you know B is 4 centimeters because of the 3, 4, 5, okay? I really recommend that you remember this because it can help you a lot to go faster with some exercises, okay? Alright guys, good job. I hope you understand for this exercise, and we will do another one now. Alright guys, so before we continue on the next exercise, I want to show you something. This is a mistake that a lot of students make, okay? And I want to explain to you why it's wrong so that you don't do it this year, okay? So many students, they know how to do this, okay? They have a right triangle, so they will write Pythagoras like we did before. And they know that they don't want c squared, they want c. So they say, okay, I want to take the square root here, okay? The square root of c squared is going to be c. And sometimes they say this, they say, oh, if I take the square root here, I have to take the square root to everybody, right? I have to, there's a square here, there's a square here, so I have to take the square root everywhere, yeah? But when we do this, what happens? So the square root of c squared is c, that's correct. The square root of 3 squared is 3, and the square root of 4 squared is 4. And when we do this, we have c equals 3 plus 4, that is 7. Is this correct? No. You guys remember 3, 4, 5. When we do the exercise before we find the answer is 5. So why is this wrong? So what is the mistake that the students make? It's not that you have to give the square root to everybody one by one. You have to give the square root to everybody all the numbers. Okay, I show you. It would be more clear if I write for you. Okay, here we give the square root to all the numbers one by one, but the square root on the left side here there is only one term, but we do the square root to everybody. And here, doing the square root to everybody, it means to write like this. Okay. Here we have done the square root to the left, we have done the square root to the right. Okay, that is correct. Because now how do we find the solution to this? So now if we want to simplify, to make the right side more simple, we cannot do anything. We have to work on the numbers inside of the square root. Okay, we have to say 3 square is 9 and 4 square is 16. Okay, together they make 25. And now you can try to remove the square root to say, okay, 25 is 5 square, and now you find, okay, c is equal to 5. All right, so you really have to give the square root to everybody, or if you don't, your answer will be wrong. Okay, and that's why I prefer to work with the numbers first. You remember when I had the equation, sorry, I'm gonna write it again. So when we do Pythagoras here, we write that c squared equals 3 squared plus 4 squared, right? And the first thing I do, I put the numbers together, I put the like terms together before I take the square root to have the c. Okay, it's better because you will not make a mistake easily if you do like this. Okay, but it's also correct if you do the square root first. Okay, if you want to take the square root to the left first, and then you have to take the square root to the right, but give it to everybody. Okay, then you will not make a mistake. If you do the square root to everybody one by one, you will make a mistake. Okay guys, I really want to explain about this because I know many students will make this mistake. Alright, and why we have to do like this with the square root is the same as these equations here. Okay, I write 2c equals 2, and now I write 2c equals 1 plus 1. Okay, 1 plus 1 is 2, so I write the same thing. You know, 2c is like 2 times c. I don't want 2 times c, I want only 1c. So you know that I have to divide by 2. Okay, I divide by 2 on the left, I have to divide by 2 on the right. Okay, when we do this, we find that c equals 2 divided by 2 equals 1. Alright, but a lot of students, they make this mistake sometimes. Okay, they know that you have to divide by 2 because you don't want 2c, you want only 1c, but they will write something like this. Okay, 2c divided by 2 equals 1 plus 1 over 2. And if we do this, okay, 2c divided by 2 is c, but 1 plus 1 over 2 is 1.5. Okay, is not 1. Okay, so that's why I say you have to give it to everybody. How do we do to show that you divide by 2 to everybody? Here we have to use the brackets. Yeah, you remember guys the brackets? Here, if I write like this, it means that the divided by 2 is to everybody. Okay, I have, if I want to expand, we say expand this one. If I want to write this one another way, is you remember guys, I said we give to everybody 1 over 2 plus 1 over 2. Yeah, you guys remember this one? Here, I used to write like this. Okay, and now 1 over 2 plus 1 over 2 is 2 over 2 is 1. Okay, this one is equal to 1. So this is correct. Okay, this is the same thing with the square root. Remember, you have to give to everybody. Okay guys? Alright guys, another exercise, example number 2. So it's almost the same as before. We have a triangle ABC, and we know two sides. Okay, I tell you here, AB is 4, BC is 5, and we want to know AC. So it's almost the same as before, but I just changed 2 sides. So here, if you look, we know the hypotenuse, and we know one of the other sides, but there's one side that we don't know. Okay, the side I call it A. So what do we do here? So if you're a very smart student, you remember the 3, 4, 5. So here it's very easy to see that a is 3, right? Because 4, 5, the next number is 3. Okay, but in this video we try not to be very smart. Okay, we try to learn for everybody. So I will show you the way to do if we don't remember the 3, 4, 5. All right, and why we have to do like this with the square root is the same as these equations here. Okay, I write 2c equals 2, and now I write 2c equals 1 plus 1. Okay, 1 plus 1 is 2, so I write the same thing. 2c is like 2 times c. I don't want 2 times c, I want only 1c. So you know that I have to divide by 2. Okay, I divide by 2 on the left, I have to divide by 2 on the right. Okay, when we do this, we find that c equals 2 divided by 2 equals 1. All right, but a lot of students, they make this mistake sometimes. Okay, they know that you have to divide by 2 because you don't want 2c, you want only 1c, but they will write something like this. Okay, 2c divided by 2 equals 1 plus 1 over 2. And if we do this, okay, 2c divided by 2 is c, but 1 plus 1 over 2 is 1.5. Okay, is not 1. Okay, so that's why I say you have to give it to everybody. How do we do to show that you divide by 2 to everybody? Here we have to use the brackets. Yeah, you remember, guys, the brackets? Here, if I write like this, it means that the divided by 2 is to everybody. Okay, I have, if I want to expand, we say expand this one. If I want to write this one another way, is you remember, guys, I said we give to everybody 1 over 2 plus 1 over 2. Yeah, you guys remember this one? Here, I used to write like this. Okay, and now 1 over 2 plus 1 over 2 is 2 over 2 is 1. Okay, this one is equal to 1. So this is correct. Okay, this is the same thing with the square root. Remember, you have to give to everybody. Okay, guys? Okay, guys, so we're back here. We have a right triangle. Okay, this is the hypotenuse. Here, hypotenuse is 5 centimeters, and then we have the adjacent side and the opposite side. One is 4 centimeters, the other one is 8. Okay, we want to know how much is 8. So first thing we do, we write Pythagoras, hypotenuse square equals adjacent side square plus opposite side square. Okay, all right, up, come here, make on 1 line. Okay, hypotenuse. So in the last exercise we don't know the hypotenuse, but here we know it. We know that it's 5. Okay, so we write 5 square equals adjacent side square. So let's say the adjacent side is 4 plus the opposite side square. So we're going to say the opposite side is 8. All right, we write Pythagoras with the numbers from the exercise. Okay, 4, 5, and 8, and we get this equation here. 5 square equals 4 square plus 8 square. So it's almost the same thing as before, but it's a little bit harder. Okay, but we still have one equation with one variable. Okay, variable is a, and this is the equation. So we can find one solution. What is this solution? How do we find it? So here it's a bit more tricky to find the solution because we have numbers on the two sides, right? Here there is 5 square and here there is 4 square. So you can solve this, you can find the solution different ways. The first thing I'm going to do, we try to make it more easy to read. Okay, we're going to say that 5 square is 25. Okay, 5 times 5. 4 square is 4 times 4, 16. Alright, when we just write this, it's a bit more easy to read. We have 25 equals 16 plus a square. Okay, first step. Second step, what do? We want to have something where we have the equal sign and one side is only numbers and one side is only variables. Okay, we want to have something like this, right? We would like to have a square equals something. Okay, so we have to get rid of the 16 here. How do we do this? Again, many students have a different ways to see that. The way I will show you, I will write it another way. I will say now I put the a square here, and I put the 16. Okay, I just, instead of writing 16 plus a squared, I write a squared plus 16. Okay, you know, when we have plus with plus, we can change the numbers. 1 plus 2 equals 2 plus 1. Yeah, okay. And in the last example, I told you about the opposite in math. Okay, when you don't want something, you have to use the opposite. In this situation, I don't want plus 16. Okay, I don't want a squared plus 16. I want only a squared. So remember, the opposite of plus is minus. If I don't want plus, I have to minus. Okay, I don't want a squared plus 16. I want a squared. So I do a squared plus 16 minus 16. And when I will do this, plus 16 minus 16 is 0. So now I'm back to a squared. I have only a squared. But you know, if I do the opposite on one side, I have to do it on the other side. Okay, this is very, very important, guys. When you have an equation and you do something on one side, you have to do it on the other side. Okay, very, very important. So if I do the minus 16 here, very good. Okay, I have 0. So I have only a squared on this side. But I have to minus 16 on the other side. Okay, and now on the left side, I have 25 minus 16. That is 9. True? Okay, and now we have this equation. 9 equals a squared, or a squared equals 9. Maybe for you guys it's more easy to read this way. I know a lot of people, they prefer to have the variable on the left side, but it's exactly the same thing. Okay, so I will write it for you guys like this, but if I write it like this, same thing. Okay, all right. So a squared equals 9. What do we do now? So now it's the same thing as the example before. Okay, we have a squared, but we don't want a squared. We want to know a. We want to know a equal something. If we don't want a square, we take the opposite, the square root. Okay, so I have to take the square root if I don't want the square. I take the square root on the left. I have to take the square root on the right. Okay, so I have to take the square root here too. Now, the square root of a squared is a, so that's cool. That's what we want. We want a equals something. And the square root of 9, what is it? So to find the square root of 9, I have to write 9 as something square. Okay, and you know 9 is 3 times 3. 9 is 3 square. Alright, so if I write like this, now it's easy. Okay, the square root of 3 square is equal to 3. So a equals 3. Okay, and that's cool because that's, I told you about the 3, 4, 5, right? So we find, yeah, a equals 3 centimeters. Okay, I hope you guys understand how to do this. All right. Alright guys, so this one is an exercise that I really like. Okay, so I read it for you. So I have a triangle, and I know that the sides of my triangle are 5, 12, and 13. And I'm asking you, do you think it is a right triangle? Right? So now, I don't want to know one side of the triangle. I just want to know, I know all the sides already, and I want to know if this is a right triangle. How do you think we do that? Okay, so I made a drawing for you guys. So we have a triangle. We don't know what it looks like, but I just know that one side is 5, one side is 12, and one side is 13. And I'm asking you, do you think this is a right triangle? If it was a right triangle, which one would be the hypotenuse? The hypotenuse would be 13, right? Because the hypotenuse is the biggest side. And then the two smaller sides would be the adjacent side and the opposite side, okay? So if this triangle with these sides is a right triangle, it would look like this, right? Now, how can we know if it's a right triangle or not? The only thing we know about right triangles is Pythagoras, right? This is the lesson. In Pythagoras, he says that in a right triangle, the hypotenuse square is equal to the adjacent side square plus the opposite side square, right? Okay. How can we use this to find if a triangle is a right triangle or not? So in the other exercises, we know that the triangle is a right triangle. So we know that we can do Pythagoras. But we can also do it the other way. if we have a triangle and we know the three sides, well, if the three sides make this equal come true, okay, if we can write Pythagoras with the three sides, then it is a right triangle. Okay, we do it the other way. Before we know it's a right triangle, so we can do Pythagoras. Now it's the other way. If we can do Pythagoras, then it is a right triangle. Okay, so here what do we do? So I just told you, if this triangle is a right triangle, it would look like this. Okay, 13 would be the hypotenuse, and then 5 and 12 the adjacent side and the opposite side. So let's try to write Pythagoras this way. Okay, hypotenuse would be 13, adjacent side would be 12, and opposite side would be 5. Okay, now let's see if this equal is true or not. 13 square is 169. 13 square is 13 times 13 is 169. 12 square is 12 times square, 144. And 5 square is 5 times 5, 25. How much is 144 plus 25? It is 169. Okay, so we found that the relationship, the Pythagoras theorem, is true. The hypotenuse square, 13 square, is equal to the adjacent side square plus the opposite side square. So 5 square plus 12 square. Yeah? And so the meaning of this is that this triangle here is a right triangle. Okay, guys? You cannot make a triangle with these sides, 5, 12, and 13, if it's not a right triangle. Okay, and I will challenge you guys. Okay, if you can make a triangle with these sides 5, 12, and 13, I will give you 1,000 bats. Okay, guys, so I'm really sure about what I'm saying. This is another way to use Pythagoras. Okay, if we know the sides, we can tell if the triangle is a right triangle or not. If you can do Pythagoras in this triangle with the sides, then it is a right triangle. Okay. Alright guys, so that's the end of this video. Thank you for watching. I hope you liked the video. I'm sorry, I know it's a little bit long. That's because I try to explain everything I do when I do the exercise. Okay, I know some students already know a lot of things, so maybe it would be very easy for them, but I also know that there are a lot of students who have a lot of problems with math. Okay, they don't know so many things about math, so that's why I try to explain everything again. Okay, about how to do the equation, how to do the square root, the everything, so that I hope everybody can understand this and can understand Pythagoras. All right, guys. So let me know if you did understand the exercises. If you did not, you can let me know in the feedback, or you can write to me in classroom. So now everybody should be able to do Pythagoras in a right triangle, okay, to do these easy basic exercises. So with this video, I'm going to give you a small quiz with some easy exercises. Okay, you can tell me the answers. I want to check that you guys understand and you know how to do this. And in the next video, we do more like harder exercises with Pythagoras. We will see how we can use Pythagoras to do some harder exercises. Okay, now maybe you think, well, it's not very useful, but we can use Pythagoras to do a lot of other things. Okay, like find the area of a triangle in a square. Okay, I will show you guys all about this. But for now, I want to make sure everybody knows how to do the simple exercises of Pythagoras. Okay. Alright guys, so I'm done with this video. I will see you in the next one. So you guys take care and do your best.